Hi guys, myself Manoj.M. In this video, we are going to solve this practice problem 3.2. Find the voltages at the three non-reference nodes in the circuit of figure 3.6. Okay, yeah, you are seeing this question. We need to find the V1, that means voltage at node 1, and V2, that means voltage at node 2, and the V3, that means voltage at node 3. Okay, we know that the KCL states that means Kirchhoff current law states that the sum of current entering the node is equal to the sum of current leaving the node. Okay. Yeah guys, let's solve the problem. Let's apply KCL at node 1 here. For this, the current here entering is 4 ampere and there are two leaving currents. One is this side and the another one is this one. Okay, yeah. I will slightly move this above. Okay. Let us write apply KCL at node 1. Okay. Yeah. We know that KCL states that the sum of current entering the node is equal to the sum of current leaving the node. Right? Yeah. Yeah, guys. The current entering is 4 amps. Let's write 4 here. 4 is equal to, and the current leaving is the V1 minus V2 by 3, the first one, and the second one is V1 minus V3 by 2. Okay, yeah, let's write that here. V1 minus V2 by 3 plus V1 minus V3 by 2. Okay. We need to make this denominator as 1. For that, make it multiply by 6. Okay, 3 to the 6 and 2 3 the 6. That's it. 4 6 are right. 24 here. 24 is equal to, here it will become, when we cancel 3 and 6, it will become 2v1 minus 2v2. Here it will be 3v1 minus 3v3. 2 3 are 6. That's it, right? Okay. Yeah, guys, let's add this. Okay. 2 plus 3, we know that 5. Let's write 5v1 minus 2v2 minus 3v3 is equal to, right, 24 here. Let us consider this as equation 1. Let's slightly move this side. Okay. And then let us apply KCL at node 2 here. The current entering is this one, and in this side here 4ix also entering, and the current leaving is ix. Okay, let's write apply KCL at node 2. Okay, yeah. We know that the KCL states that the sum of current entering the node is equal to the sum of current leaving the node. Okay, yeah. Let's move this. The current entering is V1 minus V2 by 3 and the 4ix, right? Yeah. Let's write here V1 minus V2 by 3 plus 4 Ix is equal to, then the current leaving is Ix. Okay. Yeah. Right. Ix here. Here it is grounded so that here V is equal to 0 volt. Okay. Yeah. Then let us write V1 minus V2 by 3. 4Ix minus Ix is equal to 3Ix. Right. Plus 3Ix then equal to 0. Okay, yeah, we know that Ix will be equal to V2 minus 0 by 4. That is V2 by 4. Right? Ix is equal to V2 by 4. Okay, V1 minus V2 by 3 plus 3 into V2 by 4 is equal to 0. Okay. And then we know that we need to make this the denominator as 1. For that, multiply it by 12. Okay, multiply this one by 12. It will become 4v1 minus 4v2 and then plus, here it will become 3 into 3 9. V2 is equal to 0. Okay, and then 4v1 9 minus 4 is equal to 5 plus 5v2 is equal to 0. Let us consider this one as equation 2. Okay, and then we need to apply KCL at node 3. Okay, here the current is entering and here the current is leaving and here the current is leaving. Okay, and then right, I will slightly move this here. Apply KCL at node 3. Okay, yeah, slightly move this above. Summation in the sum of current entering the node is equal to the sum of current leaving the node. Summation in is equal to summation I out. Okay. The current entering is V1 minus V3 by 2. Okay. V1 minus V3 by 2 and the current the leaving is one is the 4ix and the another one is V3 minus 0 by 6 that will equal to V3 by 6. Okay, yeah. I will slightly move this above 4ix and then plus V3 by 6. Okay. Yeah, right. And then we know that the Ix is equal to V2 by 4, right? V2 minus 0 by 4 that will equal to V2 by 4, right? Yeah. Write it here, okay. V1 minus V3 by 2 is equal to 4 into V2 by 4 plus V3 by 6. Let's cancel this 4 and 4. Okay, and then write V1 minus V3 by 2 is equal to V2 plus V3 by 6. We need to make the denominator as 1 for that. Multiply by 6. Okay, yeah. And then it will become 3V1 minus 3V3 is equal to 6V2 plus V3. Okay. And then write 3V1 minus 3V3 minus 6V2 minus V3 is equal to 0. Okay, right? 3V1 and then minus 6V2. We know that minus 3V3 minus V3 is equal to minus 4V3 is equal to 0. Let us consider this as equation 3. Okay. Yeah. Let us write equation 1, 2 and 3 here. Let's write equation 1, 5V1 minus 2V2 minus 3V3 is equal to 24. This is the equation 1 and then equation 2, 4V1 plus 5V2. We can write plus 0V3. It is not necessary we can write or we cannot write. There is no problem in that is equal to 0. When we substitute in the calculator it will help, so that's why I write. Okay, and then write equation 3, 3V1 minus 6V2 minus 4V3 is equal to 0. This is the equation 3. Okay, I will open the calculator to solve this equation. Yeah, right here click on mode setup, then click on that equation, that means 5, and then click on it is in the form of this anx plus bny plus cnz is equal to dn, then click on 2. Okay, here 5 is equal to and then minus 2 is equal to and then minus 3 is equal to and then 24 is equal to and then 4 5 0 and then 0. Okay, and then 3 minus 6 minus 4 and then 0. Okay, and then click on equals. V1 is equal to 32 volt. Yeah, guys, let us write V1 is equal to 32 volt and then open the calculator and again click on equals and then click on SD this one. V2 is equal to minus 25.6. Okay. V2 is equal to minus 25.6 volt, and then V3 is equal to open the calculator and then click on equal 62.4 volt. Okay. Yeah, right. I will slightly move this above and we will put a box to it. That's it. Yeah. We have find the node voltages V1, V2 and V3. I hope you understand how I solved this problem. We have successfully find the node voltage V1, node voltage V2 and node voltage V3. If you have any doubt, you can comment in the comment section. I hope you understand how I solved this problem. Thank you for watching, guys. If you didn't hit the like button, please hit the like button. If you didn't subscribe my channel, please subscribe my channel and press the bell icon. Thank you for watching, guys.